Alright, I'll be recording this as a video in case it helps someone else or I need to go back to it in the future. This is the first attempt at doing a multi-agent RAG system consisting of 3 sub-agents and then one orchestrator. Um, in this particular case, this is attempting to create an agent um, to help employees um, by retrieving information from SOPs. In this case, I am using Amazon Selling Partner Support SOPs um, to do the exercise. I also did it in video because I decided to use Milvus as the vector database and I set it up in Docker. So it's easier for uh, us to check how it works instead of having to create the Docker uh, file on a separate computer. Um, so it works pretty much the same as the other ones. You connect to the Mailbus service that you have. In this case, I'm running in a local host. Create a database, just a default database. Um, and then, well, this is in case a collection was made. Collection is where we're going to store our vector databases. In this case, I created the collection scheme. In here, I created fields, so that's what it's going to store. ID for each uh, chunk, the text that contains each chunk, metadata, and then the embedding of the chunk. I have to change this here because that's 384. Okay. So yeah, I just did a debugging here just to see how the database, the final schema looks. So that's how it looks. Um, those are the data files, data types. Then I proceeded to create the collection in order to load the documents. So I had the documents here on a file of SOPs, which are PDFs. Um, so with just the Python PDF loader, I just converted them and then started loading them to the vector database. Um, and then, well, using the text splitter, I did a chunk size of 1500 and an overlap of 100. And then for the embedding, uh, I've been using this one. I'm not sure if it's the best one, but it's the one I could find for free. I found out that Milvus is quite picky about the data format when inserting it. So I had to create it, I had to make it into rows. Uh, so like each row has text, then the metadata, then the embedding. And then that's what I uh, inserted into the vector database, um, which was called rack collection. So I inserted the rows, and here it says loaded 355 documents from 189 PDF files. That's because of the chunk size. So some PDF files were transformed into 2 different chunks. Here's the index. I just used the most common one that was recommended on their uh, talks, but I do have to look up a little bit more into what they do and what's the best one for each different scenario. So far, this one has worked fine. So just test to see if the collection loaded, flushing, and then how many entities we had. Um, entities 355, so that's all of them. So that's the whole indexing process done, running in Milvus. Um, so now for the agents, I'm using Olama. I changed from, I was using Gemma, but it was just not working. Um, like in some specific scenarios, so I just changed to this version of GPT. Here's the embedding model again that I've been using. And then here are the tools that I created. So tool number 1 is search local SOPs. So this is for the first agent that is going to be looking up local documents. So it's going to search the internal SOPs for relevant procedures. So here we're just generating embedding for the query, searching in Milvus, looking for the top 3 most relevant documents. SOPs are really specific, so this could even go down to 2, just for the purpose of practice. I set it at 3. If there is no search results, which shouldn't happen, it's just gonna say that there's no relevant SOPs. And then we're just formatting the results and then returning them. Then the second tool is the web search for information that is not covered in internal SOPs. In this specific scenario, this shouldn't be used often, since most questions should be on the SOP if this is a tool used by employees at Amazon. No reason for using this, but here it is for practice. And then for sub-agents, there's this agent number 1, which is the local document agent. So here's the prompt. Here it just says to look up the local SOPs and then provide step-by-step answers based only on the SOP content. And then clearly state if the SOP doesn't contain the answer, because these are like official procedures, and always cite which SOP or document you're referencing. The workers need to verify them on their notes when they finish the case, so they need to know where the SOP came from. And then this is our web agent. So he will just use the search web tool to find information online, and then also cite sources. Use this when internal SOPs are insufficient. So pretty simple on that. And then the synthesis agent, this one combines results because it receives the input, so it doesn't need a tool. Maybe in the future a tool can be like correct, just to avoid extra code. But I just did it as just receiving it as parameters. He will always prioritize SOP information and then enrich with web info. If there's conflict between the info, always trust the SOP. And then we start here with the whole multi-agent and using LangGraph. So the router node, this one is the one that decides which agent to call based on the question. So in here we're gonna be asking the LLM router to decide. So he's gonna analyze the question and decide if it's about Amazon Seller Central. Here are some examples. Respond with the keyword local. And then if it's a general question or current event news, then respond with web only. So we run this, and then that's our decision. So depending on that, that's the path we're gonna take. I do know you can use conditional edging, which I used below. I just want to try with an if. So if it's local, it just goes to local, else it just goes to web only. If it's local, it just calls the local RAG agent that we saw before, and then returns the local answer, and then goes to the web agent next to enrich the information. And then if it's web, it's just gonna look that up on the internet. Then this node decides whether to synthesize. So if he got a local answer first, it means he can enrich it with web information. So he's gonna synthesize it. If it didn't go through the local answer, then we're just gonna use the web answer. So that's gonna be the end. If he can use both, then so he's gonna start synthesizing. So if you are getting the local SOP answer, the web answer, and then combining these using the synthesis agent to get a final answer. And then the finalization node This was the case that I was previously talking about if the web answer is the final one, if no synthesis is needed. So here's the state graph. Here are the nodes. Here's the edge, so the start using the router. Then here's the decision. Here's the conditional edge I was talking about. So to route the decision. So if it's a SOP question, it goes to local first. If it's a web question, it goes to, well, if it's a non-SOP question, it goes to web. After local, always enrich with web. After web, then you have to decide if it had local answer, combine both. If there was no local answer, just use web. So both of these lead to the end, and then we compile the graph and we get the question. So easier way to see it is in LangGraph. Also, it took a while, probably due to the amount of also like printing I was doing just for debugging. I did something to take into consideration. So yeah, first the router. This is getting the question. So how to create a removal order. Then we go to the local SOP. Oh, here's the route decision. Since it figured out that it had the like things related to Amazon Seller Central, it decided to say local, which was correct. Then we go to the local LLM, and he starts looking for the information. In this case, let me see if here shows up. Here. So it's gonna look up for 3 SOPs that we said, and it's gonna score them depending on how similar or how close they are to what we're looking at the question. Here's the question. Create a removal order SOP. So in this case, it looked up 3 of them, and then it found the one. Document creating a removal order detail report right here. So once after that, final output after doing the whole evaluating the documents is just creating a removal order. So that's correct. Then here's the whole web process. This is the one that I've been seeing that takes the most. There's definitely some improvement on the web process because I saw before that it just goes really wide. So I started talking about deportation orders in the US immigration law. So there should be a check here that if it's way too wide, just avoid all of this. Because it just doesn't add anything to the question. Then on the synthesis, the output, again, this is also something to fix because it's just clearly seeing that the web, like the web tool got something completely unrelated to it. So it just explains here that the immigration law is unrelated. Here also explains why the immigration law is not relevant. And here it also gives us the sources. So like the employee can use the exact name of the Amazon SOP. And final answer, here it is. It gives the step-by-step. It also tries to make it as a table, which is something I'm pretty sure I can quickly fix on the prompt. So that's something I'll be fixing. Because it does look messy to read as of right now, because it tries to make it as a table. But yeah, it also still prints the explanation of why he didn't add the web search method. And that's something that should be just like visible on the debugging side. But yep, that was it. Definitely room for improvement. missing memory for the agents, and I'm pretty sure there can be more tools added that can add like easier steps for them to take, or just if he can find the correct SOP, like the exact one, he shouldn't go using the web search. But